Good morning, grade 7. We will now move to third quarter. This is now third quarter. Take note, okay? Hopefully everybody is already done with the second quarter. I opened activities for second quarter last time, okay? The second quarter, I think weeks 5 to 8, okay? That is actually the one stuck by the typhoon Odette, okay? So that is one way for me to help you out, okay? Now, you'll be tackling about force, motion, and energy for the third quarter. This is weeks 1 to 4, okay? Your modules are already up. I already submitted also modules for the offline learners, okay? It is actually now in school. I submitted it early as possible. And of course, I already uploaded all the activities for weeks 1 to 4. That is good for 1 month, okay? The 4 weeks being joined together as one, right? So, by the way, how is everybody doing?
Not too bad myself.
Why? How about others? Are we all good?
Yes.
I'm fine.
Still recovering?
Yes. Traumatized by
This
the
is the
wind
reason behind.
speed.
If you're going to look at your activities in the LMS, can you access your LMS? The activities there is actually lesson. Okay, imagine for how many weeks you'll be doing around 3 to 4 activities or 1 to 3 activities, I think. Let me check. So it's quite a good number for you to do. Okay. That is one way for me also to help you out with regards to our certain scenario. Okay. Let's move now to force, motion, and energy. Let's take a look at how force is being generated, the motion itself, and this energy it carries. Okay. The velocity, the speed. Okay. Let's calculate all of them all throughout. Let's move forward. A reference point, let's start with a reference point, is the starting point you choose to describe the location or position of an object. Like for example, if I am here in Mambaling, my reference point is from Mambaling going to Southbrook, for example. So that is actually your starting point, okay? Or the position of an object, okay? Each description of your location also includes your distance and direction from the reference point, okay? Describing your location in this way defines your position, okay? A position is an object's distance from and the direction from the reference point. Okay, how many kilometers? So those are the distance, okay? From the reference point, of course, okay? We cannot calculate a distance. We cannot calculate a position if there is no reference point. A complete description of your position includes a distance, a direction, and a reference point. Motion, on the other hand, is the process of changing position. If you constantly changes position, you are creating a motion. Okay? If you move your body from left to right, from right to left, you are actually what? Creating a motion. Okay? Without movement, there's no motion, of course. Without changes. Suppose distance and displacement. Let's take a look at what are the differences between distance and displacement. Suppose a baseball player runs the bases, okay? Distance is the length of the path the player runs. Okay, that is the distance. Okay, while the displacement is the difference between the initial position and the final position of the object. Okay, meaning to say that you are now calculating from the reference point going to the final position. Okay, that is displacement. Okay, so if you're going to calculate or check on the distance, this is the distance. Correct? This is the distance.
Yes.
But if you're going to look at, on the other hand, the displacement, okay, the displacement again is from the reference point going to the final position. Okay, this is now the displacement. Correct? Speed and velocity. Do you have any questions so far?
No.
These are just the
No.
basics. Okay, I actually managed to summarize sum up all of them in order for us to have a concrete idea of the certain topic. Okay, speed and velocity. Speed is a measure of distance of an object travels per unit time. Usually this is meters per second or kilometer per hour. Okay, you can calculate the speed by dividing the distance traveled by the time it takes to go that distance. Okay, the units of speed are units of distance divided by the units of time. Okay, let's take a look at this one. I have sample problems here later. Okay, the SI is the unit of speed. The SI for the unit speed is meters per second. And of course, kilometer per hour in your speedometers in your cars. Okay. The constant speed is the rate of the change of position of which the same distance is traveled each second. So that is constant speed. The rate, like for example, you are running around 20 kilometers per hour. Wow. Or you're running around 30 kilometers per hour. So that is actually constant speed. Okay. If the speed of an object is not constant, you might want to know its speed in a certain moment. Instantaneous speed, in other hands, instantaneous speed is the speed at specific instant in time. You can see the car's instantaneous speed on its speedometer. So the one that you are actually observing in the speedometer is the instantaneous speed. Are you familiar with the speedometer? Your car?
No.
Yes.
In the car ba, there is a speedometer there. So once you accelerate, the speedometer rises up. Okay. The reading there is your instantaneous speed. The instant speed on that specific time. Okay, like for example, you're accelerating around 30 kilometers per hour or around 40 kilometers per hour. Yeah, that is your instantaneous speed in that certain period. Okay, do I make myself clear?
Yeah.
Yes.
Okay.
Yes.
Again, constant speed is the rate of change of position in which distance is traveled each second. Okay. While instantaneous speed is the specific instant. Okay. The speed at the specific instance. Okay. One good example is the speedometers of your car. Right? Describing an object's speed is easy if the speed is constant. What if? But how can you describe the speed of an object when speeding up or slowing down? Okay. One way to calculate its average speed. Okay. So how can we check? We usually use what averaging method or the average speed. Okay. The average speed is the total distance traveled, okay, divided by the total time taken to travel that distance. Like for example, your speed, okay, is around your distance is around 30 kilometers. Okay. Okay, you're actually traveling around 30 kilometers. Okay. And then it takes you about 1.5 hour to complete the 30 kilometers run. Like for example. Okay. So you need to divide, okay, the distance traveled divided by the time. Okay. You already taken that distance traveled. So that is one way to calculate the average speed. Okay, take note. If an object is not in constant motion or constant speed, okay, we can actually check on them, or we can actually calculate its average speed, right? So I have a lot of problems here concerning to constant speed or constant speed traveled, and of course, the changing or the constant changes in speed. Okay, it could be slowing down, or it could be accelerating, decelerating. So hopefully we can actually grasp some of them. Please ask questions if in case. Okay, I want you to ask questions with regards to our discussed topic, in order for me also to give you an assistance or to assist you with your concern. Right?
All right.
By the way, your periodical tests and your mastery test is fast approaching. So please, Travis, inform your classmate. Are you with us, Travis? Okay.
Yes.
Can I ask a favor again?
Okay.
Okay, please inform your classmates that I'll be uploading this in the LMS. And of course, I'll be checking their papers. The offline learners, I already collected some of those papers here, and I'll be checking them one by one and recording them. Right?
Okay.
Aside from that, Travis, please inform them that the major exam is fast approaching, the third periodical tests, and the third mastery test is fast approaching. These are included in the mastery test and the periodical tests. Right?
Okay. I
As
have
you
to
can
log
observe
into
again,
Messenger.
the module here is from weeks 1 to 4. Okay? Meaning to say, this is a collection of 4 weeks. Okay? All the lessons are incorporated here, and I actually lesson all the activities. You can calculate the average speed using the equation. So this is now the equation. Average speed is equal to distance, total distance, over total time. Okay? Or v, velocity, is equal to distance over time. In this case, the v symbol represents the term average speed, distance over time. Example, okay, Melissa shot a model rocket for around 360 meters into the air. Okay, it took the rocket 4 seconds, okay, to fly that far. So it rises per second. What is the average speed of the rocket? Okay, what is the average speed of the rocket? So again,
90.
in answering, I think I already told you about this, how to answer equations, how to answer problems with, with scientific problems, by the way. So this is one scientific problem. In answering scientific problem, you need to give first, okay? You need to indicate what are the given, okay? In this case, we have the distance, which is 360 meters, okay? And the time, which is 4 seconds, okay? The next thing to do is what is being asked in the problem. We need to check on what is being asked in the problem. Like for instance, in this case, the question here is what is the average speed of the rocket? So it is actually asking for the average speed. That's the time now that we can actually use, or we can formulate our own formula, or formulate a formula out of the question. Okay? Because it is asking about average speed, we will give what is the formula for the average speed. V is equal to distance over time. Okay? And then solve 360 meters, okay, divided by 4 seconds. because it took 4 seconds for that rocket to fly that far. For 260 meters, it took around 4 seconds. So 360 divided by 4, that is equal to 90 meters per second. It's 90 meters per second. Is that easy?
Yeah.
Everybody, are you still with me?
Yes.
Okay. So I actually simplified all of them in order for you also to incorporate them. Okay. Again, science is not hard. It depends upon how you comprehend, how you analyze on the situation. Velocity, often describing just the speed of a moving object, does not completely describe its motion. If you describe the motion of a bouncing ball, okay, for example, you would describe the direction of the ball's movement. Was it moving forward, backwards, left, or right? Okay, both speed and direction are part of the motion. Again, motion is changing the direction of an object, correct? Velocity is the speed and the direction of the moving object. That's the velocity. Speed, at the same time, the direction of the moving object or the motion of that certain object. So it is now a what? A chunk of speed and a chunk of a moving object. It forms velocity. How about acceleration? Okay, I had just discussed a while ago that if a car accelerated, okay, it changes its speed. It is not constant anymore. Okay, how can you check its speed? Using, well, you can actually use this speedometer as your instantaneous speed. Okay, once the car accelerated, okay, that's acceleration. Other term is deceleration. Okay, deceleration is the exact opposite or exactly opposite with acceleration. So it now decreases its speed. So let's take a look at acceleration first. Imagine riding a car, the driver steps on the gas pedal, okay, and the car moves faster. Moving faster means the car velocity increases, okay? The driver then takes her or his foot off the pedal and the car velocity decreases, okay? The driver turns the steering wheel, the car velocity changes its direction, okay? Or the direction changes. The car velocity changes because it is what? A combination of speed and are you still with me? What is again velocity? A combination of speed and
Motion.
motion, correct? Because it now tends to incorporate the direction of the car, direction of the object, correct? Okay, when a car velocity changes, okay, the car is accelerating. Okay, acceleration is the measure of the change in velocity during a period of time. Okay, an object accelerates when the velocity changes as a result of increasing speed. Again, as a result of increasing speed. Again, please ask questions if there are certain topics or certain terminologies that you might find it really hard so that I can unlock those, okay? An object accelerates when its velocity changes as a result of increasing speed, decreasing speed, or changing in direction, or changing directions. Again, velocity changes as a result of increasing speed, number one, decreasing speed, and changing of direction. Acceleration is a change in velocity divided by time interval during which the velocity changes. Let's take a look at the formula later, right? Recall the velocity is the speed of an object in a given direction. Okay, again, speed and motion. However, if an object moves along a straight line, so one direction, you can calculate acceleration without considering the object's direction because, again, you're moving in a straight line. Okay, you're moving in a straight line. Just like when you actually calculate the speed of a falling apple. Okay, the gravitational pull. Okay, we're not actually considering the what? The motion because it is actually moving in a one direction. Are you with me?
Yeah.
Yes.
Okay. So again, recall that velocity is the speed of an object in a given direction or a combination of speed and motion. However, if an object moves along a straight line, you can calculate acceleration without considering the object's direction. Okay? Velocity refers to an object's speed only. Okay. In this case, positive acceleration can be thought, okay, of speeding up in the forward direction. Then on the other hand, negative acceleration is slowing down. Negative acceleration is the same with deceleration. Okay, this is the slowing down in the forward direction as well as the speeding up in the reverse direction. That this is negative acceleration. Okay, this is now the formula for your acceleration. Okay, we have final speed minus initial speed divided by time or total time. Okay, A is equal to VF or velocity final. Okay, VF is final speed minus VI or initial speed over time. Right? So somebody asked me, I think that was last month, January. Okay, he actually asked me about, sure, where can I find the initial speed? How can I solve this one? Okay, if it doesn't actually indicate the initial speed there, therefore you will start at 0. Okay, final speed minus 0, so that you can actually get the VF minus VI over time. As simple as that.
Wait, what does VF mean?
Velocity final.
And VI?
Initial. It's in there. I means initial. Okay. This is common. This formula, you can actually encounter this one all throughout, even in college. Okay. Please take note of the formula. Yes, the initial speed is where, again, the speed started at. Okay. Sometimes in the problem, we usually put the initial speed. From 30 kilometers per hour, okay, the traveler runs at the speed of 80 kilometers per hour. So we have initial speed and the final speed. But if the initial speed is not indicated there, therefore, you need to put 0 as the initial speed. So starting from rests. 0 means starting from rests. Okay. By the way, do you have any questions so far?
Oh,
No.
no.
About others? Mariana? Jairus? Jayden? All right. So let's have this example. A bicyclist started the rest from rests. Okay, along the straight path. after 2 seconds, his speed was 2 meters per second. Okay. After 5 seconds, okay, his speed was 8 meters per second. Okay. What is the acceleration during the time of second and 2 seconds and 5 seconds? So it is actually now asking about acceleration during the time of 2 seconds and 5 seconds. We are now talking about acceleration. Okay. Again, in answering scientific problem, okay, we need to indicate what are the given. Okay. In this case, we have the initial speed. Okay. Aside from it started from rests in a straight line, okay, it actually indicates the initial speed, which is 2 seconds. Okay. The final speed, which is 8 meters per second. Okay. And the time given, which is 5 seconds final time. Okay. Time final and the time initial. Okay. Are you still with me?
Yes.
Okay.
Yes.
In the case, if you're going to look at it, okay, sir, how can you calculate that one? It has 2 times there. Okay, it has 5 seconds and 2 seconds. Take note that there is an initial time given. Okay, if there is an initial time given, you need to use the formula. What? Time final or final time minus initial time to get its total time. Are you still with me?
Yes.
Okay. So 5 seconds minus 2 seconds, this is 3 seconds. So now you can now what? Substitute. Okay. Acceleration is equal to 8 meters per second. Okay. 8 meters per second minus 2 meters per second, your initial speed or your initial velocity, over the 3 seconds, which is the difference between 5 and 2 seconds. Okay, substitute. 6 meters per second, because 8 minus 2 is 6, divided by 3 seconds. Because there is a 2 seconds here, tendency is it will become squared. So acceleration is equal to 2 meters per second squared. Are you still with me?
Yeah.
Yeah.
Okay. Do you have any question with the problem?
No.
Can you say it again?
What is ms? Is it meters per second?
Meters per second, because we're asking about meters per second here. Okay. What else? It's meters per
What
second.
about the 2?
Come again, RJ? Was that RJ?
Yeah.
Yes, RJ.
Like it says m/s and 2.
Meters per second squared.
Okay.
You are confused, Travis? Yes, Travis.
Yes.
Question.
I am now confused of the difference
Yes.
of ms and m/s.
M/s. Meters per second.
What's ms?
Meters per second.
Teacher, can you say the formula again? I
Acceleration is
couldn't
equal.
understand.
Huh? What's wrong? I did not get your point. Meters per second squared. Oh,
I am not confused anymore.
what's wrong with that? Are we good with
We
meters per second
somehow
squared?
got confused.
Huh?
Yeah, we're fine with it now. We're fine with it.
Ah,
Just somehow
okay.
got
So you're
confused.
actually confused about where did the meters per second squared came from, correct?
Sort of for me.
Correct. Huh?
For me, I think so. Or yeah.
Okay. Meters per second squared came from this. Okay. If you're going to divide, because we're talking about 2, okay? If the lower part or the denominator, if this denominator has a meters also, the result here is 2 meters squared per second squared. But because this is on the second, because we're pertaining to time, okay, we actually incorporated this in the meters per second squared. Okay, this is the basics of mathematics.
If the
Division.
time was hour, is it meters per hour?
If time is hour, it
Yes.
depends upon, because in the given situation, if you're going to look at it, it is expressed, okay, it is expressed in meters per second. Okay, and what if the time there is hour? Sure, meters per second per hour? No. You convert, again, you convert the time into seconds in order for you to substitute. That's a good question. Any other question?
Nope.
Any other question? By the way, these are the basics of mathematics. Okay?
Wait,
Sure, is
science has
mathematics
math.
connected to science? Yes, there is a connection between mathematics and science. There is, especially in calculations. Any other question?
Can you say the formula
No.
again?
Formula? Acceleration is equal to final velocity minus initial
Yeah.
velocity over time.
Yeah.
That one?
Yes.
RJ?
No, it wasn't me.
Any other question?
Nope.
No questions.
Violent reactions. Are we good with this? You still have around 3 minutes.
Wait, do we have a quiz today?
Are we all good with this? I might give, if in case.
We're good.
I'm still doubting a bit with MS for some reason.
I understand.
Huh? What's the problem with the MS? It's in the given, so you need to follow the given. I have a lot of problems here, so I can actually give it to you if in case. So that we can have a clearer view of this problem. But of course, there are a lot of twists, for sure. All right, let's move forward. Okay, with a quiz. Are you ready?
No
I am
Okay.
not
Problem on
sure.
problem.
Hopefully by next meeting, I can give some quiz, some activity, okay, in order for you to solve there and share it to the class, right?
What about
This
the
is pertaining
activity
to
2?
speed, velocity, acceleration, and of course the motion. Okay, these are interconnecting body, interconnecting topics. These are intertwined, meaning to say you cannot actually remove them from the system because they are connected to one another. That's the essence why we need to discuss acceleration, why do you need to discuss velocity, why do you need to discuss motion and speed. Right? Question so
Yes.
I
far?
just realized we're in science. I thought we were in math.
Because this is under physics. And this is, again, you can actually check them out, or you can actually handle them all throughout, even in college. I am just preparing you. I am just giving you a bit of information, as simple as possible, so that you can actually have a grasp of what is really the topic all about. Right? Again, we will have a series of activities by next meeting. Hopefully, a seat work. We will not make it as a quiz. We'll make it as a seat work and share it to the class. This is under, again, for your your written works and class standing, if in case. All right. Do you have any questions so far? It's less than 1 minute.
No.
I
No
think that will go for today's
questions.
class. Thank you for your participation. Hopefully, we can do a lot of activities by next meeting. I had prepared a lot, a lot of problems here. Yes, Mariana, you're raising your hand. Okay. I think that will go for today, class. Have a nice day, everyone. Take care, grade 7. I am really happy to see you. Have a nice day. Take care. Bye-bye.
Bye.